Trigonometry, Chapter 1, Trigonometric Functions, Section 2, Angle Relationships and Similar Triangles, Video 1, Intersecting Lines. The series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the last section, we discussed two types of angle pairs. One was complementary angles, two positive angles whose sum is 90 degrees. Recall that complementary angles, when together, form a right angle. And supplementary angles, two positive angles whose sum is 180 degrees. Recall that supplementary angles together make a straight line, a straight angle, if you will. In this video, we explore more pairs of angles, but this time, angles formed by two intersecting lines. Here we have a picture of two intersecting lines and kind of a circle marking off four arcs, two in red, two in blue. For reference, we're going to label these four angles with four Greek letters: alpha, beta, theta, and omega. Omega, this is the one that looks like a W. Now, within these four angles, there's two types of pairs, one of which we've already discussed, namely the ones that are supplementary. Supplementary angles are formed by any two adjacent angles formed by two intersecting lines. Any two adjacent angles formed by two intersecting lines are supplementary, adjacent meaning that they share a side. There are four supplementary angle pairs formed in this picture, and they are alpha and beta. Notice they share a side. Beta and theta share a side. Theta and omega share a side. Omega and alpha share a side. Adjacent angles formed by two intersecting lines are supplementary. The other type of angle pair are vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. In this picture, the vertical angle pairs are the same colors. In this diagram, there are two pair of vertical angles: alpha and theta, beta and omega. Vertical angles are congruent. I thought about proving it, but it would take up too much time for this 5-minute video. Now for a quick clarification, the word congruent, which I used here, vertical angles are congruent, essentially means the same shape and same size. And concerning angles, congruent means angles with the same measure. The symbol for congruent is an equal sign with a wavy over it. We write angle A is congruent to angle B to say that the two angles are congruent. To say that their measures are equal, we would put the M in front of it and say the measure of angle A is equal to the measure of angle B. Just remember, congruent compares objects, equal compares numbers. For this first example, see the diagram below. Suppose the measure of angle AEB equals 120 degrees. Find the measures of the remaining angles. Well, first, let's take advantage of the fact that vertical angles are congruent. Which angle is the vertical angle to angle AEB? Which is the non-adjacent angle? It's the one at the bottom. Recalling that vertical angles are non-adjacent angles formed by two intersecting lines, the vertical angle to AEB is CED, this angle down here. And since they're congruent, the measure of angle CED is 120 degrees. Now, either of the remaining angles are adjacent to either of the two known angles, and since adjacent angles formed by intersecting lines are supplementary, both of the remaining angles have a measure of 60 degrees, 180 degrees minus 120 degrees. Just remember, every pair is either congruent or supplementary. Let's take a look at one that's a little bit more algebraically involved. Find the measures of all the angles in this diagram. We're marked with one angle with 7x plus 5 degrees and another angle with 10x minus 55 degrees. The trick to this is to figure out how the angles are related. And these two angles are vertical angles because they're non-adjacent angles formed by two intersecting lines. So their measures are equal. So we need to solve 7x plus 5 equals 10x minus 55. This is just an algebra problem. We're going to start by subtracting 7x from both sides because there's too many x's. That would turn the 10x on the right into a 3x and make the 7x on the left disappear. Now we're going to get the x by itself. Add 55 to both sides. On the left, that'll leave 5 plus 55 is 60. and then divide both sides by 3 to get x equals 20. But be careful. This is not an angle measure. This is the value of x. Since x is equal to 20, we can substitute it into the angle measures. 7x plus 5 ends up equaling 145 degrees. And when we substitute it into 10x minus 55, we also get 145 degrees. That was expected. Vertical angles are congruent. What about the other two angles? Well, they're supplementary to these angles that we see, so we simply have to subtract 180 minus 145 to get 35 degrees. Now you try. Pause the video and try the following problem. Find the measures of all 4 angles in this diagram. All right, if you haven't paused it and tried it, now's your last chance. I'm about to reveal the solution in 3, 2, 1.